Hi everyone. This is a video for Year 10 Extension students who need a topic to study beyond the regular work program. So you're watching this video if you finish everything early and there's time for you to do some preparation for maths methods in Year 11. In this video, we're going to introduce the topic of quadratic equations. And really, if you're losing track of the big picture, this is what we're trying to do. If I give you a quadratic equation, ax squared plus bx plus c, and just so that you know, quadratic means there's an x squared term. How do I solve this equation? It's not immediately clear. We can't just use inverse operations the way we did with linear equations. We're going to need other techniques. In this video, I'm going to introduce the most basic technique, which is called factorization, something that you'll have already done in Year 9 and 10 algebra. We'll soon see that this method is not very efficient and we'll need more powerful tools. But in order to appreciate those more powerful tools, we'll need to first be comfortable with factorization before using those more sophisticated methods. So let's get underway. What I've written on the left is the expanded form of some algebraic identities. And I just want to jog your memory of how we factorize these expressions. You might like to pause the video and see if you can factorize these yourself before I go through the answers. So the first one you should recognize is a difference of squares. And that can be broken up into x plus a times x minus a. The next two are sometimes called perfect squares. And these can be factorized into the form x plus a all squared and x minus a all squared. And this last one, you probably haven't seen it written like this before. So I might just show you the full derivation. So I'll start by expanding this bracket using the distributive law. So this is x squared plus ax plus bx plus ab. And what I'm noticing is the first two terms have a common factor of x, and the second two terms have a common factor of b. And then what I'm noticing is both of these terms have a common factor of x plus a. So I can use the technique of factorizing by grouping to rewrite this as x plus a times x plus b. And what I want you to note is these two numbers a and b the middle terms add up. So these two numbers a and b add up to the middle term a plus b, and they multiply to ab. So I'll just write this maybe in a different color so that it's clearer. And you might remember this is how we factorized certain quadratics in Year 9 and 10. So just wanted to jog your memory by maybe writing it in a form that you haven't seen before to remind you of a technique that you knew. This method, by the way, when A and B are numbers, requires trial and error. It's not easy to just pick the numbers A and B straight away. So we'll see that in a few examples to come. So one other thing that we need is what's called the null factor law. So if I have any two numbers, I won't say can be any number. I'll say that they represent numbers. So if I have two numbers which when multiplied together give 0, then either A equals 0 or B equals 0 or both. And the reason for this is any number multiplied by 0 gives 0 as a result. So for example, 5 times 0 is 0. So if I give you a pair of numbers A and B and they multiply to give 0, then at least one of those numbers has to be 0. And we're going to exploit that to solve quadratic equations because if we can factorize them, we've broken them up into factors. And if the factors multiply to 0, then one or more of those factors in brackets has to be 0. So let me show you what this looks like. Okay, so all of these equations are going to be quite simple. They're going to be written in the form something equals 0. So we only have one strategy right now, and that is to factorize. So let's start with this one. X squared minus 25 equals 0. You might recognize 25 as 5 squared. And so this is a difference of perfect squares, which means I can write x plus 5, x minus 5 equals 0. So that means either x plus 5 equals 0 or x minus 5 equals 0. In other words, x equals minus 5 or x equals 5. And we're done. An alternative way to approach this equation is to say x squared equals 25 and x equals plus or minus root 25. I'm also happy for you to do this at the year 10 level as long as you understand that when I take the square root, there are two possibilities if I allow x to be negative. So x equals plus or minus 5. You can't throw away negative 5 unless you are explicitly told x is positive. And we assumed that when we were doing calculations involving Pythagoras. But if you're not given a restriction like that, you need to consider both solutions. Okay. For the next one, this is taking us slightly outside the focus of this lesson, but I just want you to note that 17 is not a perfect square. So what I can do is write this as root 17 all squared, and this is now a difference of squares, and that equals 0. And now I can say x plus root 17, x minus root 17 equals 0. Hence, x equals negative root 17 or x equals positive root 17, applying the null factor law. Alternatively, I could have written x squared equals 17 and then taken the square root of both sides. But I have to remember this gives me two possible solutions, one positive and one negative. So in general, if x squared equals a, where a is positive, then x equals plus or minus root a. When I write this symbol square root, I mean the positive square root. So this is always going to give me a positive number. And therefore, if I want to include the negative solution, I need to write plus or minus. For the rest of these questions, we won't need to worry about this because we're not dealing with surds. So just note, root 17 is a surd. If you haven't already learned about surds, let me know. I can give you some exercises on that, but you'll do some work on this in year 11 as well. Okay, let's keep going with some examples. So here I've given you the equation x squared plus 18x plus 81 equals 0. And what I want you to notice here is that this is equal to x squared plus 9 times 2 times x plus 9 squared. Remember that x squared plus 2ax plus a squared equals x plus a all squared. So this is actually a perfect square. So I can rewrite this as x plus 9 all squared equals 0. So here I've got a repeated factor x plus 9. So you can think of this as x plus 9 times x plus 9. All of that equals 0. And so this time there's only one possible solution, x equals negative 9. Because I'm saying what's in the bracket, x plus 9, has to equal 0. In the bottom, I've got x squared minus 14x plus 49 equals 0. And if you remember your perfect square formula, if I have minus 2ax in the middle, this is going to give me x minus a all squared. So I can write this as x squared minus, I might just rewrite the 2 and 9 in the opposite order. So x squared minus 2 times 7 times x plus 7 squared. And notice that the 7 is the same number in both the middle and at the end, so I can use the perfect square formula. So x minus 7 all squared equals 0. And that means what has to be in the brackets has to be 0. So x minus 7 equals 0, or x equals 7. The hardest part about solving equations like this is that I have to remember or recognize the perfect square form. All right, let's keep going. Here, I've given you x squared plus 5x plus 4 equals 0. And experience should tell you that this is not a perfect square. And so I'm looking for a factorized form, x plus something equals 0. And I've got two numbers that need to add up to 5 and multiply to give 4. So I'll just write the note there for those of you who've forgotten. They should add up to the middle coefficient and multiply to give the constant term 4. And for us, those numbers are 4 and 1. So x plus 4, x plus 1 equals 0. And now if I apply the null factor law, the brackets have to be 0. So x plus 4 equals 0, or x plus 1 equals 0, which means x equals negative 4, or x equals negative 1. Okay, part F. I might give you a moment to think about this, maybe consider pausing the video. Because now you've got negative signs, so you may need to just remind yourself of what you did in previous study. I want you to notice that there's a plus sign here. The numbers that we choose in brackets should add to negative 12 and multiply to positive 27. And if they multiply to a positive number, that means either they're both positive or both negative. If they're both positive, when I add them up, I'll get a positive answer. But since I have a negative sign here, I need to choose two negative numbers. So that narrows it down to x minus some number, x minus some number. And now I just need to choose the right numbers. I need numbers that give me 12 when added together and 27 when multiplied. And those numbers are 3 and 9. So just check. Minus 3 plus minus 9, that gives me negative 12. And minus 3 times minus 9 gives me 27. And that equals 0. Hence, x equals 3 or x equals 9. Okay, one more example and then we're done. This one cannot be solved with the usual techniques that we have outlined in this because the coefficient is 2 rather than 1. So we're going to have to use trial and error. But I claim that this is the form that we're looking for. So 2x plus some number and x plus some number are my factors. Why does this work? Because if I take 2x times x, I get 2x squared. So now I just need to choose these terms. Maybe I'll call them p and q, such that 2 times q plus p gives me 17, and p times q gives me 21. There's only a few options to choose from. There's 1 and 21, and 3 and 7, and this time I have to consider let me say, the order matters. So if I put p equals 3 and q equals 7, that will give me a different result to p equals 7 and q equals 3 because I've got this number 2 here on the left. So now that I've given you that, I'll just sort of give you the answer. What we're looking for here is p equals 3 and q equals 7. So here is my factorized form. And now I'll just write out the working out that you might use if you're using the null factor law. So either 2x plus 3 equals 0 or x plus 7 equals 0. I skipped this step previously, but for an equation like this you might find it helpful. So now I need to rearrange both equations for x. The first one gives me x equals negative 3 on 2, and the second one gives me x equals negative 7. If I gave you any quadratic equation that was more complicated than this, it would quickly become impractical to factorize. Factorising is nice when it works, but most quadratics cannot be easily factorized. In fact, most quadratics have square roots in their solutions. If I change this number 2 to say the number 8, I wouldn't be able to solve this anymore using this method. So, in order to comprehensively solve ax squared plus bx plus c equals 0, for any given combination of a, b, and c, we're going to need something different. Something more general and something more powerful, and something that's frankly easier to do, because factorizing is really time consuming, error prone, and I don't like trial and error. I want to get straight to a solution. So in the next 2 videos, we're going to learn new methods. The first one is going to be called completing the square. So this will be video 2. And then we will generalize this to the quadratic formula, which will be in the 3rd video. I look forward to seeing you then. Take care.